Yeah, welcome to iOS Club. Today we're going to be going over pin drop. And one of the main things you'll be learning is MapKit, which is just one of the APIs you can use to show a map within your app. It's an alternative to Google Maps, but with Google Maps API, you have to like import a CocoaPod or do different things like that. MapKit comes, with Swift, so in iOS, so it's less overhead there. But the main thing we're going to be teaching is actually data persistence. So you see these pins here. You can create a pin. So let's say I zoom in on like California here and just say, I don't know, what's something in California? The beach. And I can just say it's like my favorite place. I don't know. And then it's actually in California on the beach yesterday. And all right, cool. So we added that to the map. But in part in this thing at the top, the status bar, it just would have taken more code to fix. But so let's say that I open it back again. So you see I terminated the app by swiping up on it. And it's still there, right? These pins are still there. So normally, like everything we've done up in this club so far up to this point, you make something and then you quit the app and your data's gone. So we did the Note app, I think, last week, right? And in the Notes app that, 2 weeks ago, what you've seen here. And you would create these notes, right? Or reminders, whatever you call it. And then you quit the app and they're gone. So how can we save these objects to the device? So, yeah, everyone just open up Xcode and make a new file, which you've probably done before, but for me, I'm going to make it down here, but yeah, new project, you've probably already done this. Single view app, let me do it here. So I just made a single view app. Storyboard for today. Next semester, we're going to do a series on Swift UI in the fall. So be sure to come to that. But let's just call it like pin drop or whatever you want. And then, yeah, we don't need any of these things. Yeah, should be fine. Swift. And then I'm just going to save it to my documents here. All right. So is everyone good up to this point? And make sure that your storyboard can load.
What was the template that you used?
Single view. That's what we're doing for all the iOS club. Just single view. Just whatever the first thing that comes up is. Yeah, just call it pin drop. Are you still on it? Is anyone still No? All right. So make a new file. And the way there's different ways of doing this, but I'm actually, you see I'm on the storyboard. I'm going to right click on any of these files in here and do new file. So right click and do new file. Yeah, so when you start a new project, you have to make sure that, I would just delete that and start over, but when you do new project, you have to make sure that you select storyboard, not Swift UI. So you do single view app, and then right here, it needs to be storyboard, not Swift UI. So I would just start over on that one, that project, just delete it, or you don't have to delete, just make it pin drop number 2. Swift UI and Storyboard are 2 different ways of making iOS apps nowadays, and come to iOS Lab if you're interested in Swift UI. It reduces the amount of code you have to write. All right, so once you're in main Storyboard, make a new file by right-clicking and make it a Swift file, and do pin.swift, and then create. So again, just right-click here. Make a new Swift file. Could also just be an empty file that you do .swift on, but yeah, it doesn't matter too much. Just make it a Swift file and call it pin. And this is going to be our data object that's going to represent what a pin is. Okay, everyone good there? Yes. So I just made a new file called pin. I'm going to call it struct pin. And then what's a pin going to have? Like a name. A caption, right? Because if you look at this thing here, they have a name and a caption. When you hold down and press on a pin, there's a name and a caption. So we're just trying to figure out like what's in a pin. So there's a name, there's a caption, they're both strings. There's a latitude, which is a double, and a longitude, which is a double. That's about it. Yeah. And we're going to do extension pin for MK annotation. Okay, so actually we have to import MapKit. You'll notice I'm actually starting, and this is the traditional model view controller approach of, I'm starting with the model layer, right? You can think of the main.storyboard as the view. There's no logic in there. And then there's the pin, which is the model, and then the view controller is the controller. And this is the MVC architecture. So instead of putting all your code in the view controller, something weird like that, we're separating it out. And I'm starting here because storyboard's a little more complicated to navigate. So yeah, extension pin. And then it's saying something interesting. It's saying non-class type pin cannot conform to this class MK annotation. So it's basically saying that it has to be a class type. So if we change this to class, then it should be fine. Okay, but then it says class pin has no initializers. And if you look at this, which is good if you're a beginner, just seeing like what's it saying, like if I do fix here, it could put like an initial value for each of these, right? And it's going to do that for the rest of them, right? But we don't want that. What we want is actually an initializer. But you notice that we didn't have an initializer, and this is the same as a constructor in Java, or I don't know what you call that in Python, probably a constructor as well, init as well. So yeah, basically you don't need an init for a struct, but you need it for a class. And it looks just like you would expect in Java or some other language. You could have, name, string, caption, string, lat is a double, long is a double as well. Now I'm actually going to use these buttons here to give me more room. And then I'll do self.name equals name, self.caption equals caption, self.lat equals lat, self.long equals long. There's ways to speed this up, but it's nice to just manually write it out to get used to that. And the reason why we're doing this again is because to make it a MapKit annotation, which you can think of as like something that's going to go on the map, it has to be a reference type. It has to be a class. Now, I'll explain what that means in a minute. And then, so that should be pretty straightforward. But like this initializer, it's similar to other languages besides Swift. But then it's saying that we need to add protocol stubs for MK annotation. And so it has all these different things. It's like, like, do we really need to specify these? No, because what we really should have done is subclass NSObject here. And NSObject, as you can see in this thing that comes here, it's the root class of most Objective-C class hierarchies. So basically, it's an Objective-C class that is bridged into Swift that has all these different methods and variables that come along with it, such as what's its superclass, what's its ID, or things like that. All these things that it wanted us to specify here to be an MK annotation, right? But now that we do that, and then we see, okay, you want to add protocol stubs, it's really just one thing. It's a coordinate. That's the only thing we actually needed when we subclass NSObject. And subclass, who here is like taken 1331 or hasn't taken it? Who's taken 1301? Just raise your hand. Who has not taken like object-oriented programming? No one? All right, so everyone's familiar with objects, right? Okay, well, I'm going to review it anyways because you never know. it's good to review in with the Swift context anyways. So, all right. Yeah, we're talking about objects and data persistence. So classes versus structs. You might notice here that we start out with a struct, but by default, it was almost like by default I used a struct, and then I switched to a class. So what's up with that? And it's because it needed a reference type. Well, what's a reference type? So there's two object types, and well, there's actually multiple types. There's also enumerations, which are treated as objects, first-class objects. But the point is, classes and structs are two ways to accomplish the same basic goal of data encapsulation, right? We could just be passing around like a tuple of name, caption, lat, and long around everywhere, but we want something that, you know, can be subclass, something that, or not, well, not in this case subclass, but we need something that can have, for example, can inherit different things, or conform, in this case, conform to MK annotation. Or we basically, what we need is an object, and an object just wraps these things up as, seems like all you know already. But what's the difference between a struct and a class? Because they're both ways to encapsulate this data into an object. Classes are reference types. So if you change a class in one point, and it affects it everywhere. So UI view controllers are a class, if you think about it. Like, let's go to like UI view controller. Or, sorry, it's just view controller, right? It's just this file that comes built in here, viewcontroller.swift. It's a class, right? Now this enables, it's a reference type, which means that if you pass this view controller around to like another view controller and you edit it, or you change anything about it, say you change the view controller's view, or you change its background color, it changes the original one. But structs, on the other hand, right? Structs are passed by value. So it's copied on write. So if you pass, let's say that in some weird, well, not a weird world, Swift UI, views are actually structs. So it's kind of similar to like a UI view controller. You got this view and it's passed by reference. So you can't mutate it, right? Like you can't mutate it from another place without copying it on write. So if you want to mutate a struct, you actually create a copy of it. So this is actually important for also subclassing, right? So you can see here that view controllers are subclassing UI view controller, which means that it comes with a ton of built-in capabilities. And if you command click like I just did into UI view controller, you can see the Swift like header file, you could say, of just the definitions of the different variables and things that it conforms to. Look at all this that a UI view controller is doing for us. And the implementations of these things are hidden from us, but Swift is open source, so, but UI view controller is not Swift, it's actually an Objective-C file. But anyways, you can look more into that in your own time, but basically we're subclassing UI view controller to come with all this built-in stuff. But if pin was a struct, it doesn't come with this built-in, all these built-in things. So since it's a class, because it's forced to be a class to be an MK annotation, we have to conform to NS object to have all these built-in things. And the reason why MK annotation has to be a class, I'm not sure. It probably says in here though. Yeah, so I'm guessing that basically if you have a mapped pin and you change it from somewhere else, it should change the same pin. You don't want to have duplicate pins floating around with different object identifiers. Like you want to have a consistency there. That's what I'm guessing. So, but for whatever reason, it has to be passed by reference. So I hope that makes sense, classes versus structs. It matters in the beginning. To you, probably the most it'll matter is that you have to write an init for classes. So, yeah. So yeah, classes versus structs. Will this build? Yes or no? Actually, it probably will. The thing is, if you got rid of this equals 0 for both width and height, you should be fine because you don't need an init for a struct because then it doesn't auto synthesizes the initializer for you, right? You've probably seen this in your own code, but with a class, you need an init, or you need to specify, like, okay, default values for this. All right, and we're going to talk about data persistence later. So that was just a rundown on classes versus structs. Before I go on, any questions on that?
Is the question mark allowed for the
I'm not sure. Because the thing is, if it's this, then it's probably automatically nil, right? And the way you could test that out is if you go to View Controller and you add a new value in here and you call it color, UI color, it's going to complain, right? Has no init. If you add a question mark, then it goes away. Yeah, because this is the same as doing equals nil. For some weird, I don't know why, but that's just probably a hack. But yeah.
This optional doesn't need a value, right?
It defaults to nil, I guess. So, but yeah, you don't need to memorize that though. That just happens to be something that happens there. Any other questions on structs versus classes?
Structs are like immutable, like strings.
Yeah,
They're mutable.
exactly. String is a struct.
They are mutable, but you would mute the object, not the reference. It's like if it came from somewhere else, the original object would not change, only the one you.
Yeah, I wouldn't. Yeah, I wouldn't get too caught up in the terms. Just think about like a string is a struct because I just did Shift Command O and search for string, and to Swift, you can actually look up like on GitHub the Swift open source library for string. You can see how it's implemented, and yeah, you if you change like. We actually have a second, so I can do this. If you made a new playground, playgrounds are awesome, by the way. If you're ever trying to figure out something with Swift, I still use them all the time. Do this. So I just did file new playground. So, oh, look. All right, so there's already a string. And if I do string2 equals string, and then I do string2 dot, I don't know, pop last, is that? Remove last. Okay, sure. And so based off of what you know, strings are structs. And then let's say that I make a new class. What's a class? Like I could say, okay, we already imported UIKit, so I can say let view equal UI view. And then let view2 equal view. And then view2 dot background color. Oh wait, yeah, equals dot red. And then here we can do UI views are classes, and then reference type, and then this is a value type. And so basically we're copying it over. So this is actually creating a new variable, like new memory object, like allocating new memory for a new string. And then this is just another pointer to the same object. So when you do this, it sets views background also to red. So then here I can do like, you know, print. Well, you don't need to do a print. Well, you could just do like string here. And then here you could do view dot background color. And then if you hit this play button, you'll see that hello playground, this string does not get changed, but view does get changed. Yep. So again, yeah, this hello playground string did not get changed. So when we set this over, and this is how it should be. This is how programming should be in most cases. Like when we make something equal to something else, we want it to copy over because we don't want to mess other things up. A good example I think I saw on WWDC once, it's called like value semantics in Swift or something like that. And they said, what if you have like a class, a reference type for like temperature, and it's like a temperature object. And I think it's like you set the temperature object in your home. You have one object, and you say let temperature equal 75 degrees, and you set it to your thermostat, right? You say thermostat.temperature equals this temperature object, which is my house's temperature. Well, if you change your house's temperature now to 407, not house temperature, you then create a new temperature object and you say let oven temperature equal the other temperature of 75, and then you do on a new line, let this oven temperature actually like dot value equal 200 degrees. Well, because it's pointing to the same object, this new thing, your oven temperature, is now going to set your house temperature to like 200 degrees and you're going to die. So, yeah. Just letting you know.
Can you print STR2?
View 2?
Or STR2?
What do you think it would say here?
In Java, it would just be a love language. That's basically what you said.
Oh, yeah. Well, the thing is about append, it's a mutating function. So we're getting a little too far ahead of ourselves for this talk. But basically, in a struct, if you want to change it, you have to write mutating in front of the function. It's about all you need to know for now. But it's just an extra syntax you have to add in front of a function that changes itself. So, yeah. We can talk about that later. Anyways.
Wait, can you run it once?
Oh, yeah, right. Yeah, so it did mutate it. And you can think of this like there's this thing called an extension if you're interested. And you could do an extension on string and say, my non-mutating append. And then it is going to return a new string. And then you could have, whatever in there that just returns like, a new string. Or you could have a mutating func, which actually changes self equals, something like that. So that mutating keyword is key there. All right, so back to this, and where were we? Yeah, so basically the extension. All right, now we have a good understanding of why this needs to be a class and what the difference between a class and a struct is. I'd recommend sticking to structs to start, and then if it has to be a class because you have to subclass something, then make it a class. All right. So coordinate. Let's make it a. So it has to be a CL location coordinate 2D. So we're going to do that with the latitude being, self.latitude and then self.longitude. And you can omit the return statement here, right? Because typically we would say return. You can omit that in Swift5. But that's basically the same as return. And this is, I believe it's called a computed variable. Basically just like a variable that's, when you call it, it recomputes it on the spot. And then there's some other optional things you can add to an MK annotation. So if you jump into this definition, you see that these are optional, right? Title and subtitle. But let's go ahead and make a subtitle. And this one is just going to be self.caption. That makes sense, right? We're basically conforming to this protocol. I believe it's a protocol. Should be. Yeah, it's a protocol. Protocols are for another talk. But you can think of them as an interface. So in Java, right? It's like the protocol says you have to, if you want to be an MK annotation, well, you first have to be a class. And the reason why you have to be a class is because it says here, well, it says if you jump into it, in this object protocol. So that's just why it says it has to be a class. But protocols by default don't have to be, you don't have to be a class to extend them or to conform to them. But it's like if you want to conform to this MK annotation protocol, you need a coordinate, and then these are optional. And again, if you jump into MK annotation, it tells you that much. Any questions on protocols in this case, or why we need to conform to these? Nope. I'll give you another minute to type it all out.
why do you have to, why does one make you different?
Yeah.
That's really specific to this one.
Yeah, right here it says you have to be an NS object protocol. So that's just like,
But protocols in general don't necessarily have to be classes.
yeah, that's right.
Okay.
It's like, I never even heard of this before because typically I would say here like any object, but I guess NS object NS object protocol means it has to be an NS object. I guess. But
Okay.
I haven't run into that syntax before because like if I make a protocol, you know, this protocol could be like, I don't know, like let's say you have like a pin or like you have like a class, like a struct user. That's a struct and it has like a name. And then, I don't know what that is. But then let's say that you have like a protocol that's called student and it would have like student ID. And then if I want to make user conform to student, then it's going to complain and say I need an ID. But yeah, it's a struct. So,
Okay.
but imagine if I did this, right, and then it says fixed, and I just say like it's, okay, that should be fine. And then, but what if I say student here needs to be like any object, the protocol to which all classes implicitly conform. So all classes implicitly conform to this. And yeah, it's like, okay, non-class type. But honestly, if you just saw this and you Googled it, it would say, well, you need to change this to a class. Or reconsider something else. Yeah. Any other questions on protocol? An extension, that's another object-oriented thing, which is we could just delete this and then add MK annotation here. That's the same thing. An extension is just a way to clean up your code to separate out like, okay, what am I looking at here? And one thing you can do is do mark and then do like that. And so you could also just do that here if you want, like init, and then you don't have to do this. It's just like an example so you're exposed to it at some point. So then when you click here, you see, okay, MK annotation, which is really helpful if you have like a huge class or like a huge file with a bunch of different extensions and things like that. It's just a lot cleaner to have this mark because as soon as you put this mark here, it shows up there. And so you can jump straight to it instead of having to scroll around or to use Command F or something like that. But yeah, you don't have to do that today. All right, and then let's connect this to the view controller. And then, so in here, well, we're probably going to, let's see here. If you go to main dot, yeah, let's actually go to main.storyboard. That's probably better. And then view controller, we're going to meet the two together. So in main.storyboard, if you click this plus button, storyboard takes a while to load for some people, but hopefully you're all okay with that. But search for MapKit View. Okay. So I'm just searching for MapKit View by clicking this plus button. I'll zoom in on that plus button in a second, and I drag that in. And the plus button is right here. There's the plus button I clicked on. And you search for MapKit View. All right. So now I have MK Map View, and I'm going to make my constraints just 0 on all sides. And the way I do that, as you will remember if you went to like last week's talk on constraints and all that, thanks to Nate, there's this thing called, oh crap, add new constraints. Basically just click this button. And then you hit 0 on all sides, make sure they're red, which it should be, you hit add 4 constraints. And constraint just means it, Nate talked about this last week, but basically it's just constraining the view to all 4 sides. And this is the map view. So you don't really have to do anything. If you run this app, and we haven't connected anything, right, to the code with pin, but if you run this, it actually will show you, which I recommend you do. So I'm just going to run this for fun. And yeah, it's already good to go. Like, it's a map that you can scroll around on. While that's running and building, I'm actually going to click on this view controller and do embed in, where is this thing? Oh wait, okay, well, might as well look at this. Cool. And yeah, you can run this yourself. And all we did for this was just drag in a map view, MK map view. That's it. No code necessary. So, and then I set the constraints here, 0 on all sides. So let's embed this in a navigation controller just to add like, I'm going to do editor. There's probably different ways of doing this. Oh, maybe it's this button. Yeah, embed in navigation controller. So I clicked on this guy, which gives me the view controller. Then I'm going to click on this guy, which is the embed button, and I'm going to embed it in navigation controller. We don't need it for this app. It's just an easy way to add a title. It's just some polish here. And then, so that's cool. It's just embedded in navigation controller, which I think we've been using for every iOS clip so far. And then in here, I want to change the title. Actually, you do that here. Okay, so I just clicked here, and then you can see I click on it, and let's do pin drop. Just type that there, and I'm gonna do large title always. Oh, actually, scratch that. Click on this one and do prefers large titles. Right, so I did two things here. On this navigation controller, I did prefers large titles. I checked that on. And then here, I just changed the title to pin drop. Make sure you're selecting this one, the attributes inspector, but it should be on that by default. And again, there's just pause, so if you miss it, then no worries. So then when you run it, it just adds that title to the top of the screen. While that's building, okay, that was fast. Cool, so it just added a title. And note that I'm in dark mode, and it automatically works for dark mode and light mode, which is cool. Google Maps is yet to support that, so another reason favor Apple. So yeah, pin drop. Any questions about the storyboard? I think you're all familiar with it though. Yeah, so I clicked on this. This is the thing that comes built in. And then I click this button, bottom right here, embed in, and I click navigation controller. And then once I click navigation controller, this guy appears. And if you want to add this title, then at the top here, I click prefers large titles. I turn that on. And then on this view right here, I do pin drop in the title. So yeah, all right. And now I'm going to click this plus button to add the view controller on the right. Appears kind of slow, but yeah. Add editor on the right. And I'm going to close out these side panels, as you can see, to give myself more room. I'm going to zoom out. And there's different ways you could do this. I'm going to do recent files and click view controller. So I click this thing, recent files, view controller. Different ways you can make it show up. Also, when you're on this side, you could hit Shift Command O and type in view controller. Different ways of doing it. But point is, I click this plus button. Now view controller is on the right-hand side. Everyone figure that out. And then have map view on this side. So does everyone have this? Again, I click this button here. And then I chose recent files, view controller, .swift. Yeah, all right, cool. I'm going to assume you're good. And then I'm going to hit control and drag. Oops. I have trouble control dragging. No, I'm just going to do it from this side. It's the same thing. Nope. I hit control and I drag. I'm never going to be good at this though. What? No, it's not command. It's control. There we go. You just got to try a few times. It's my computer. And here I'm going to drop it. So I control dragged on that map view. And should it be? Yeah, no, that's not right. It should, maybe it's like a tab gesture. No, it's not that. It's a, maybe they changed it. I'm trying to do like a control drag and then like an action here that says like you held down. But I wonder if we did just do like a long press gesture recognizer. Yeah. There used to be a way that I think you could do it from the map view itself, but don't worry about that. All right, so I just searched. I hit the plus button. I found long press gesture recognizer. This should work. And I'm going to drag it onto the map view. And then it shows up here on the storyboard. And I'm going to control drag it into the view controller. And I'm going to name it did long press map view. You could call it whatever you want, though. Oh, wait. It shouldn't be an outlet. It should be an action. No, correct. Action. Type. You can set that if you want. I don't think it matters. Yeah, so again, I hit the plus button. I search for long press gesture recognizer. And then I drag that onto the map view itself. And then I control drag from the map view to the view controller. Hopefully you didn't get lost in there. And then I just change the name to this. I set the action to that and the type to that. And I'm going to zoom in on this if you need. All right. If you need help, you can also raise your hand and Yassine or Nate or Malik can help. All right, so I'm going to keep going then. Oh, wait, never mind. Nate, I got a long gesture recognizer, drags on the map view, and then made an action outlet to the view controller. Oh, and by the way, you're dragging from this. You're not gonna. You're control dragging from this. From this, not the map. All right, so I'm gonna do this a few times actually. I'm gonna delete this again. So I'm gonna search for long gesture, long, drag long onto the map. Click this, control drag here, and then name it that, and change it to action, and hit connect. Yo, you see? All right. You don't need to do that. You're fine. Yeah. I don't know. Maybe you need to do that, but probably not. Oh, wait. You do need to do that. I think. Wait a second. Let me do it again. Actually, you maybe do need to do that. Let's see. No. Wait. You do need it. Yeah. I'm just going to change this to say map view. No, UI long gesture recognizer. Yeah. So yeah, you're right. You should have set that. But so one more time, if you delete this, and I'm gonna delete these guys here. Oh, I shouldn't have deleted that one. Whoops. Ignore what I'm doing right now. I did not mean to do that. Yeah, don't do what I'm doing. I just do this because I just messed up. Okay, so yeah, one more time. Long press gesture recognizer. Drag that onto the map view. Control drag. Control drag if you can. Okay, here. And then I'm going to make it press map view. And then the type's going to be that. Make sure you set the type actually. And I'm going to make it an action and get rid of this old guy. All right. So now what I'm going to do is actually make a new tab Shift Commando View Controller and get rid of this other tab. It's just for presentation. You can keep coding on the right-hand side there. I don't care. But yeah, I just made a new tab and went to this file. All right, so we have this finally. And then what we're also going to do, actually go back here and make another outlet of the map view. I'm going to make an outlet here and just call it map view outlet. Don't miss that. That's actually pretty important. So I just control drag from the map view to the view controller, and it's saying it doesn't know what that is because we need to import MapKit. So I imported MapKit. You can also just type this out yourself and then not control drag, just drag it to the storyboard in reverse if you want. All right. Looks like everyone's good with the map view there. There's some code that you can just look up on Stack Overflow because that's how I figured it out. And you're going to choose this one. All right, I'm just going to write some of this code and then explain it afterwards. All right. That's going to have a warning or error for now. Should be fine. Okay, so you should be mostly done coding, but I'm just going to explain this. We dragged out from the storyboard, we connect our map view, and then we also have a IV action function for when you do a long press. Now we could also have done just whenever you tap on the map, but it could be tricky, right? Because you do a lot of tapping and squeeze and move around in different things, pinching, I mean. And so we're just going to do a long press, but that's up to us. We just decided this. And whenever you do a long press, I'm going to get the location, which is just the sender here. If you should have this sender with, it shouldn't say any, it should say this gesture recognizer. You don't need to fully understand this right now, but basically it's like, where on the screen did you tap? Where is that in relation to the map view? And we know what the map view is because we are connected there. And then there's a method that converts that location on the screen in the map view to the actual coordinate on the map, which is pretty cool, but we don't have to write that. Someone else at Apple did that for us. And then we're going to, now that we have where that coordinate is, where you tapped, or did a long press, we're going to add a pin at that coordinate. And so I made a new function called add pin at this coordinate. And yeah, the type is just CL location coordinate 2D, which comes thanks to Apple. And that's because we imported MapKit at the top there. And then in ViewDidLoad, this is, we've probably talked about it before, but there's a view controller lifestyle for UI view controllers. And you know, there's different methods, which are basically callbacks, right? That get called at different phases of the UI view controller setup. So you might have seen view did appear, view did load, view will appear, things like that. And basically, you call super just to make sure the super implementation of this doesn't do anything for UI view controller. But let's say that you one day decide like, oh, you know, I want a base view controller that has a ton of functionality like you'll do if you have a complex app. So you subclass that instead, but you need to make sure to call super here. So it's just a good practice to always put super there. But you don't need it in this case, but anyways. And then I'm setting the MapViewDelegate to myself. And then, okay, that's an error, but then wait for a second on that. Self.loadPin. So basically, when the view loads, when it's done loading, we're going to load the pins. And it's also when it's going to be done loading the map at that point. So we have this to do, we have this to do, but first let's figure this out. Cannot assign value of type view controller to type MK MapViewDelegate. And you definitely don't want to do that. That's a horrible recommendation. What it should be saying is conform to it. So we're going to do the same thing. Extension view controller, MK MapViewDelegate. Exactly this. And then we'll see what it complains about, but it's going to need, well, not need, sorry. So we can see the, it's not very helpful. Okay, so these are some of the different things, callbacks that we can register to receive here. So let's did view for animation. I'm just going to start typing view for animation. So I just started typing function map view for annotation here. And that's just going to be whatever the view is when you tap on it. So that you'll notice this is actually pretty similar to the table view that Yassine did 2 weeks ago. I don't know why it's complaining about that when I'm using it right here. We build it to get rid of that. Okay, good. So you're still typing, but you don't need it. Again, this is not the most important thing here, so I'm going to basically skim right over it. You're returning what the view for the annotation is going to be. And you're, yeah, don't worry about this too much. The main things we're trying to teach here are how to save data and what's like object-oriented code look like in an iOS app. Structs, classes, protocols, you know, things like that. So as soon as you're done with that, we're going to go on to more important things. So I'm going to actually do that right up here and add pin. So I'm going to do self.pins. Oops, we don't have self.pins, do we? Okay, so I'm going to put it here for now, but okay. So I'm just up here real quick. Let's make like an array of pins, which again, it's pretty similar to the table view example. It is just our data source here. So yeah, now that we have that, self.pins.append. Okay, well the pin is, is anyone still on this?
Can you go to the right?
The right? Okay. I'm gonna start typing up here actually. Okay, it's actually not gonna be that simple. That's basically what we want to do. That's the goal here. But so is everyone done with this? We're just about. Oh wait. All right, I'm gonna move on. So, add pin. Let's use an alert. UI alert controller, and then we've done this plenty of times before. Say new pin. We don't need a message. Make a dot alert versus dot alert sheet, and then so I haven't left anyone behind here, right? No? Okay. So we're creating an alert. We're adding 2 text fields. Recall this. If you do a long tap on it, oh, we haven't really set this up yet. But in the old app, basically, there would be a text field for the name. There would be another text field for the caption. And then there would also be a cancel button there. Style.cancel, it's pretty useful. Just dismisses it. Alert.add action. Okay. And then we're gonna also want a save action. Pretty similar, you know, title is save, style is just default. There is a closure, just like these. We don't have enough time today to talk about this. Come back next week. Let text fields equal alert.text fields. Well, there's a guard let statement. Basically, if there's no text fields on the alert, just get out of there. Should be there though. You could throw an error if you want. And then let name equal text fields of 0.text. Then the nil coalescing just in case. Let the caption, I guess. Yeah, let the caption equal 1.text. The caption is going to be the second thing. And then let the pin equal, well, this is where our code comes in. Yeah, and then I left, basically, there might be a few lines of code here. I want you to think for yourself, like, what you think should be in there. We're almost done here. Almost. the next step is really just saving it. Just raise your hand when you're done so I know.
Can you scroll to the very top?
I added pins here. Yeah. Because we already made this pin object. That was like the first thing we did. So yeah, see if you can figure out what to do in there. Then you can run it, and it should, well, actually it won't work. There's one other thing you have to do. So I'm going to help you out here. Is let pin equal something, then self.pins.append that pin. And then there's something that you might not have thought to do, which is self.mapView.add annotation. And if you're wondering where this add annotation came from, well, it's here basically. We already did that, so yeah. All right. And then you can run it, which is the play button up there. And you should be able to create a pin, name it whatever you want. And you want to have questions on how alert works or anything here? All right, so I'm going to go ahead and put in the code here. The pin is, okay, well the name is name, the caption is caption, the lat is chord.lat, and the long is chord.longitude. Okay, so if you run that, you can create the pins, and then the last thing we have to do is actually save it to the device, which is the second most important thing after knowing what objects are. So I opened up the map, you hold down, new pin, make sure it's a long press, and then USA, I don't know. You don't need a caption. All right, cool. So it works, right? But if you quit the app, and you go to, this is the newer one, it's gone. It's not there. Okay, so that's the last thing we're going to have to do. So, anyone still coding this? Yeah.
Where's this chord? Chord.lat?
Here. Chord. It's passed into the function. One thing you could have done here is change this to say this might be a little more intuitive. You can add pin at lat and long, and then you're just going to do here lat and long, because that's just being passed into the function. Because here, when you add pin, what we're actually going to do is now change this to, no one else has to do this, it's just like longitude, and then this is coordinate dot latitude. Cool. Yeah. And that builds. Basically, it was being passed in from that long tap gesture recognizer. Is everyone done? Or I'm gonna. I suggest running it though and making sure that it works though. It's like iterative development. One of the worst things you can do is just code for hours at a time and then run your app and then try and trace back where you went wrong.
Go about the next week.
Yeah. And if anyone still can't get it to build or they're missing code, just ask Yassine or Nate because they look pretty happy to help. Or Malik. He's not doing anything. Oh, Prabir's here too. Yeah, Malik, you're kind of quiet today.
Yeah, that's true.
All right. Anyone need more time now? If you need more time, just raise your hand. We got like 4 people back there. We actually have the same amount of officers as people at this point. So, anyways, so now go to pin.
Oh yeah.
I do Shift Command O. You could also click this guy and click on pin.
There's nothing. You put it into stream.
So once you're in pin, and notice that when you run it, that when you quit the app, the pins are gone. So that's all we have to do left. That's all that's left. All right. There's a few things we have to do. Let's start by making an extension at the bottom here, and I'm going to do another mark. Good practice at this point. We're going to call it persistence. My favorite word. Extension pin. Well, we're not conforming to anything. We're conforming to codable, but I don't know if we can put it there. But we'll see. I might complain about that. Yeah. All right. They don't want you to put the extension there, so I'm just going to add it here. So at the very top of pin class, add comma codable. It's just another thing that we're going to be conforming to. And then, so once you do that, we're going to basically be codable persistence here. All right. So what we're going to do is static let pins key equal pins. Then static function save pins is an array of pin. That's just one of the methods we're going to use. Another method we're going to use is static function load pins. And this is going to be called in the view.did_load. I think it's already maybe being called. No, it's not. But all right, anyways. And then it's going to return an array of pins. But it's optional because it could just return nothing. Well, at that point, we'll just return an empty list, I guess. All right. And then in here, we're going to do if let data equals, well, save is a little bit easier, so let's start there. Let data equal try JSON encoder dot encode pins, the thing we're saving, and then there's defaults dot standard dot set data for key pins key. Don't worry about what this means. I'm going to explain it later. And then load pins. If let data equal UserDefaults dot standard dot value for key pins key as data. Oh wait. Let pins equal try JSON decoder, so we use the encoder before. Array of pin dot self. Don't worry about what this means yet. From that data, then we're going to want to return the pins, and then here we're just going to return an empty array if it didn't work. So that's it. That's persistence right there. And I'm now going to explain what that means when you're done coding it. But I started out in iOS Club my freshman year, and I didn't really know much about iOS. I thought I knew iOS. I was pretty confident, but iOS Club actually taught me a lot. Like I never knew how to like save data this well. I used all the different hackiest methods you can imagine. But this is extremely clean code. There's not that much code here, and you're saving actual data and loading it back. It's not the fastest thing in the world, but actually I made a Spotify alarm clock, which ended up doing pretty well and making hundreds of dollars a day, and it was just this simple. And I made another app, a weightlifting app, used just the same thing, JSON encoder, decoder. I even made like a video recording app that uses the same thing. So, and I really just copy and paste the code that I learned from iOS Club. Same with table view. I didn't understand that at first, so I just went to iOS Club and then copy and pasted the code I wrote in Club for a while until I memorized it, basically. Because it's not totally intuitive. So make sure that you conform to Codeable at the top here. All right, so now it's time to explain this. Codeable. If you jump into this, it's really just encodable and decodable. It's a type alias. A type alias means that it's just like another way of saying something else. And decodable means you can decode it. Encodable means you can encode it. Each of these are protocols, which we talked about before. So also, you're going to end up wanting to save and load this yourself. That's an exercise for the viewer. You're going to call those from the view did load. But, all right, so now that's codable, but what the hell are these doing? Let's look at the slides. Data persistence approaches. You could do core data, which is pretty powerful, and it does pretty well with Swift UI nowadays, actually. It's overkill for a simple app like this. And like I said, I've actually never needed to use core data in any of my personal apps. I don't think. Yeah, never actually. It's overkill for a lot of the simpler apps. So you can make a pretty profitable app without needing core data. But it's built on top of SQLite. Think of it like a wrapper for SQLite for complex queries. And then Firebase or CloudKit, these are like backend as a service, right? They're a database in the cloud for several users. It's a great place to get started. The next level up from there might be something like AWS, your own server, for example, Heroku, and writing server-side code there. Firebase we're going to actually teach later this semester, and core data you can come to an iOS lab, talk about that. But then UserDefaults is what we just used. You might remember me typing that out. And there's this property list, which is just like a dictionary. You can check out like info.plist in here. This is just like your app's data. There's a plist, right? And UserDefaults is stored in the same file type. It's .plist. And as you can see, it's basically like a dictionary, but it's XML under the hood. If you're really interested, you can right-click here, do open as source code. That's really what it is, right? But it's shown as a property list. Same thing though. All right, and so that's how UserDefaults are stored. And it's much simpler, but it takes long to load because if you change one thing in that list, it has to rewrite the whole file. And there's some other limitations like on the data types you can store. Basically, all the data types for UserDefaults, they have to be those basic things like string, data, date, Boolean, different numbers. Yeah, almost done here. And then there's an example of core data versus UserDefaults. Look at how simple this code is versus this code. Does the same thing, right? It's just like I use this in one of my apps. Actually, I started out with core data, and then I switched to UserDefaults. It was briefly because I was just trying to record how many times a user has opened my app. This was like when I first started coding, and UserDefaults is the way to go for this. It's not. You don't need the overhead of core data. So Codeable is what we just looked at, which is it's the protocol that you conform to allow encoding and decoding simple objects. I talked about before, date, dictionary, just about anything you can need. And even I've used it actually, like in my alarm clock app, for images, because you can do UIImage.encode and you can encode it to data or a string if you want. And so basically, I would encode and decode images using this too. So it's user defaults isn't too bad. Yeah, more complex objects, you must conform to codable. And that's what we did here, right? Well, you have to conform to codable, right? So we conform to codable, but it's automatic conformance, right? Because all these types, string and double, they're one of these types. But if you have some other thing like UI image, then you have to do some more things that we're not going to get into in this talk, but you can just say, like, you can probably just Google that yourself. All right, yeah, you'd have to manually conform. But if you have something that's just strings and doubles, then you're good to go. And then here's an example. You know, we have class cell, and well, this wouldn't compile for a number of reasons, but point is, codable won't work for a UI view unless you do something like decoding it yourself. So you're going to have to do some custom stuff there. But with this, it works just fine. Nothing to do with the fact that one's a class and one's a struct. The point is that UI view is not one of those types we talked about. All right, so that's about all you need to know about codable. So now if you go back to the code, and now it should make a little bit more sense. We have a pins key, which is just like the key. Remember the info.plist is this dictionary? This plist, and you call it user defaults, it's another, you can think of it like a dictionary. So imagine you see bundle identifier execute. These are like keys, right? Imagine if one of those keys was called pins. And then for that key pins in the plist that we're saving to, and this plist is user defaults on standard, we're setting the JSON encoded pins array to that key. So you can think of it setting this data like a data object, which is bytes, right? And then when we decode it, we're loading the data by getting from user defaults on standard that plist, we're getting it for the same key because this is stored to the device. You'd say like stored to disk, even though it's not actually disk. And with this code, it will actually, and it could fail, right? It could say like, oh, it's not there. Or it could say, oh, it's not an array of pins, right? It could be one pin, right? This happened a lot. You can also use this same method for decoding JSON, right? Because it's a JSON decoder. So we're actually setting the data here. Okay, I'm sorry, it's not really data, it's JSON. But encoded is, it's data encoded as JSON. So imagine if you had JSON on a Firebase database, and it's in JSON format, and you have the same format, you have like name, caption, lat, and long. Then you can decode it. So yeah, then it's left to the viewer or you guys to figure out how to implement this. You'd basically just call these two from view controller. Yeah, so that's it for today, but you can then go in a view controller and call it yourself.
You said you saved images with the user defaults?
All the time. Yeah. It's actually not that slow. Because imagine if you had like a struct that has like you'd see in this. Like, what if you have a UI view? What if you have like a UI image? But everything else, you want to save it to disk. You don't want to set up something like core data that's more involved. You just want to use defaults. So at that point,
Just convert the image to data.
yeah, what I would actually do is have the variable image be data, and then I'd have a computed variable for the UI image, which whenever you access the image, it forms the image on the spot out of the data, which you probably won't call too often. Yeah. Okay, well, I might as well call it myself then. That was about as simple as it was for loading. I could have figured that out though. And then the other thing is we have to save the pin when we make it. So when you create a new thing, I'm just gonna do it here. So wait, actually, we have pin. Wait, I didn't make it like that, did I? How did I do this? Okay, whatever. So yeah, that's the save, and this is the load. And then when you load it, I'm just going to do that. So if you run this, should be good to go. Cool, it's there. Quit the app, reopen it, and it's still going to be there. All right. Thanks for coming, everyone. And let us know if you have any questions.